Hi, welcome to the LAN boards video explaining what GVS is. GVS connections are a way of quickly and easily hooking up external devices to your microcontroller. Here's an Arduino sensor shield with a temperature sensor, an accelerometer, and an LCD hooked up through GVS cabling. The history of GVS is that it originated with servo pinouts. Servo pinout is a 3-pin connector, 10th-inch spacing, with ground, voltage, and signal. It was quickly followed in the Arduino world with Arduino sensor shields. They had a number of pins. Each of the I/O pins of the Arduino were connected up to GVS connectors, 3-pin connectors. Over the years, there have been quite a few GVS input and output devices developed. The GVS input devices there's quite a few different types of GVS input devices. For instance, passive switches. These let a microprocessor know whether a button is pushed. Here's an example of one that you can find on eBay quite freely, showing the ground VCC and out markings on the silkscreen. GVS active low switch schematic, and when you press the button, the line goes low into the microprocessor. There's also active GVS switches, which contain circuitry that drive the signal line, but they're also wired ground, VCC, and signal. Here's a touch sensor switch. There's also analog input devices that are wired up as ground, voltage, and signal. For instance, a pot can be wired up as GVS for control. Be careful when you wire up a pot, though, that you don't wire it in a direct one-to-one sort of an order, because you'll short the pot out. There's also 5-way analog switches, which are a type of GVS analog input. Little switch that has left, down, upright, and select mode and carries it all on a single signal pin. And that's done via a resistive divider and 5 individual switches inside that one part. There's also quite a few GVS output devices. An example of a GVS output device is an LED. And they come in sort of 2 flavors. One is an active high LED, and the other one is an active low LED. Also, GVS buzzers are available. They hook up to the ground voltage, and the signal line can be hooked up to a PWM line, and that can cause different sounds when you run a different PWM through it. AC power relays also are a way of controlling AC power circuits from a microprocessor, but be careful, they're not always wired GVS. You need a cable to switch the wires around. There's quite a few GVS-ish devices out there as well. They have a similar ground voltage and signal, multiple signals though usually. An example of one is I2C devices. There's quite a few of those out there. They have that, as mentioned, the ground voltage clock and data, and it's on a 4-pin connector. One type of device that you can find commonly on eBay and other places are I2C liquid crystal displays. It allows you to pretty easily hook up an intelligent device to a microcontroller. Some newer example of that is the OLED, the organic LEDs displays, which also have the 4-wire 2 signals, power and ground connections to the LED display. It's LCD display itself, organic LED. Serial peripheral interface also has ground voltage, separate data in and out, and clock lines. Here's an example of an SD card that has the SPI bus interface. It's also GVS-ish. Some devices allow you to do either SPI or I2C, and sometimes you have to solder a jumper on the board to do that. Here's an OLED display that has that sort of an option. You can see the silkscreen with multiple options. Ethernet controller chips are also done with SPI interface, and they have those for the Arduino, other microprocessors as well. Another example of an SPI device is an RFID tag reader that can provide access to buildings or things like that. There's a lot of GVS cabling options that range from do-it-yourself solutions to purchased cables. An example of an easily purchased solution is shown the cable here that would come typically on eBay. You find them in a lot of other places. So 40-pin cable, female to female, and you can strip the cables apart and do whatever you want. Additionally, you can buy pre-manufactured true GVS 3-pin cables. To make it easier to plug in, they come pre-manufactured, but be careful, the color code may not match ground voltage and signal. You can also do a DIY sort of a cabling method if you want, and buy the little plastic housings, buy a crimp tool to be able to crimp the pins. Laneboards has quite a few GVS products. We latched on to the GVS concept early on with the Arduino sensor shields. And we came out initially with a number of products for the Arduino. One of the cards we came out with that we're especially proud of was on Kickstarter not long ago, Tiny Grade 85, which is an AT-Tiny board with prototyping area and GVS pins as an option in the middle. Another board is our GVSDuino, which is an Arduino UNO compatible, which surrounds at megapart with GVS pin. Easily hook up any external devices to your Arduino without having multiple cards. We also have an Arduino Leonardo Compatible GVS-3204 card that provides similar functionality with built-in USB interface. We've also kickstarting a Raspberry Pi GVS Daughtercard. This one's for the original Model B. It has 3.3 volt translators from the voltage of the Raspberry Pi to 5 volts and GVS pins. A very similar card out for the Raspberry Pi Model B Plus. Except that we have some 3.3 volt I/O and 5 depending upon which spot you want to hook up to. We are coming out with a configurable version of the B Plus card that will have 3.3 volts all the way across the top and selectable through jumpers, whatever signals you want to convert to 5 volts across the bottom to GVS. Also on Kickstarter got a Beaglebone Black GVS cape, very similar functionality to the one for the Raspberry Pi B+. Over the past few years we've made quite a few sensors and devices that are GVS compatible. One of the first ones we came out with was the one-wire temperature sensor for the DS18B20 part. Again, a ground voltage signal connection to a one-wire temperature sensor. We also came out with that part coupled in with a light-dependent resistor to make a fan controller project. Came out with our own little GVS switch. They're available widely on the internet as well, but we wanted a real tiny one of our own for breadboarding, unlike most of our products, which are geared around being put into real deployable solutions. Came out with an I2C 8-bit digital I/O card, which lets you hook up the I2C interface and get 16 bits of dig I/O off of it. Also came out with a 16-bit version of the same card, lets you get 16 bits off the I2C bus. Another card we came out with that's GVS is an IR sensor card. It has an IR LED that sends out infrared and an IR receiver that receives it back, and you can use that to measure distance to objects. We used it with our Theremin project. We came out with an LDR sensor, standalone light-dependent resistor sensor, which has the resistor and LDR part and works as GVS. Card we're recently kind of excited about is our little LED test card. It's got 16 LEDs on it and a ring of GVS pins around the two sides of the LEDs, and you can hook up directly to the LEDs with GVS. One side is active high, the other side is active low. We showed earlier our 5-way GVS switch, up, down, left, right, select, and sends out an analog voltage. We also come out with a discrete 5-way switch again, but this time with up, down, left, right select, but this time with 5 separate buttons and a GVS analog output. Thanks for watching our video. We hope you find something that inspires your own design here.